Hello Legacy students, Marsh here. So today we're going to look at absolute value equations using transformations because I know for a fact you hated making them with tables. So we're going to do it quicker this time. But you're going to want to have that foldable I gave you, notebook, and then a writing utensil as well. So that foldable, we're going to look first at vertical shift up and horizontal shift right. So you may have noticed as you were doing your tables, there was kind of a pattern to certain things. A negative on the outside flipped the V. A value on the outside made you shift up so much. That's going to always happen. And that's kind of like when we did our translations of our lines. We talked about how to write the line and all that. Those actually going to keep coming up. So vertical shift up, what does that look like? Well, ultimately, it's going to look like a value of f of x plus k. So taking the normal parent function of an absolute value, which is absolute value of x, and adding some value on the outside of it. Basically, all it's going to do is it's going to shift the graph up so many units. So if I have the equation f of x equals absolute value of x plus 3, and I have my parent function there, if I graph him, absolute value of x plus 3, what it's going to do is going to take this v and it's going to move it boop, 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 up 3, and then the arm's going to come off on both sides. Just like that. So all it does, if I have a number on the outside of my absolute value, it's just going to shift him up 3 units. Horizontal shift right now, if you see something on the inside of your function, aka you're subtracting from the x on the inside, that's going to move you right h units. So remember, guys, kind of like how the lines, when we did x minus 3, that meant we moved right 3. Same thing with the v's. So if I have the absolute value of x minus 3, graph my parent function here just so I can get an idea of what it's going to look like. This is going to take me and move me right 3. So I'm going to take my graph and I'm going to move him right 3. 1, 2, 3. So my vertex would move here. And then I'm going to move over. Boop. Can't draw straight lines. Guess it's unavailable to me. There we go. So what I did is took my parent function here and just shifted him 3 to the right. Just bumped him a little bit over there. Now, let's look at the other 2 ways. We can vertically shift down. What that looks like is f of x, just the normal function, with something subtracted on the outside of the function. So normal absolute value of x minus a number. What all it's going to do is shift the graph down a couple of units, however many is on the outside. So I'm going to graph this guy, absolute value of x minus 3. So I have my absolute value right there. I'm going to shift down 3. So I'm going to take my graph here, I'm going to go boop, 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 down 3 units. I'm going to go do, 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 do. There's my graph. Right there. Pretty lovely, if I could say so myself. Horizontal shift left, what that's going to look like is inside the absolute value, you're going to be adding a number. It's all it's going to do is shift you left so many times. So if I have my v and I am x plus 3, it's going to shift me left. So, because think of it, this is x minus 3. Because it's always in minus there. So I'm going to shift left 3. 1, 2, 3. Right there. And do, 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 do. Whoop. I can't find where he goes. There we go. Notice he goes up 1 over 1 on both sides for my arms. My arms can always do that if I don't have a stretch or compress. Which, speaking about compression, let's talk about him. Vertical compression. What does that look like? Well, it's when you have the absolute value of x, but you're multiplying by a value that's less than 1 but greater than 0. So, what that's going to do is it's going to multiply the y values of the graph by a factor of a. So, if I have my parent there, notice, guys, that my graph, 1/2 x, what's going to do is take all the y values of this graph and multiply it by a half. So, starting at 0, 0, well, if I multiply 0 times 0, it's going to stay, or 0 times a half is just going to stay 0, right? But normally, if I gone 1 over, I would have gone up 1. So I'm going to take, if I look at my parent graphs table here, that would have been negative 1, 0, 1. I went up and at 1, 0, and 1. So I'm going to take my y values and multiply them by a half. So my new graph of 1/2 x would be negative 1/2, 0, 0, and 1/2. So at 1, I'm going to go up a half, on 2, if I've been plugging in negative 2, that would normally have been 2. So a half of 2, that would be 1. So at 2, I'm actually going to get up to 1. Notice, guys, what it's kind of doing is basically compressing it, aka flattening my graph, making it so it takes longer to get up there. So I find when doing vertical stretches or compressions, I have to do with the little table here. Some people also like the table when they're doing the shifting, and I'll show that on one of the examples here. Reflection over the x-axis, all it's going to do is be a negative on the outside of the graph. It's going to reflect across the x-axis. So in this case, it's going to be a negative of the absolute value of x. So if I have absolute value of x, normal parent graph, all it's going to do is flip across. So it's going to look something like this guy. Like that. Looking at vertical stretch now. Vertical stretching looks exactly like compressing, except your A is greater than 1 this time. So it's going to actually look like it's kind of taking it and kind of giving it a wedgie, if you want to think of it that way. It's going to multiply the y values by a factor of A. So in this case, we're going to do an example of a factor of 2. So normally my parent graph would have been negative 1, 0, 1. It would have been 1, 0, and 1. I'm going to take my y values and multiply them by a factor of 2. So my new graph would be negative 1, 2 for a dot there, negative 1, 2, 0, 0, and 1, 2. And if I take negative 2, normally that would have gone to 2. In this case, it's going to go to 4, like that. So basically, like I said, it's going to take the edges of your lines and make them go steeper. So I'm stretching, it's going to make it look steeper. If I'm compressing, it's going to make it look more gradual for a change in your incline, change in your slope of your lines. Example, what is this guy going to do? Well, looks like we got a stretch, got something going on here, something going on there. So this would be a stretch of 2, aka we're going to multiply the y values by 2. We're going to shift right 1 and down 2. So this is a stretch, this is right, and this is down. So, got my parent, let's see how it moves. When you are moving your graph, best thing to do first is shift left and right. You're basically going to do PEMDAS. You're going to do the stuff on the inside here, left and right, then multiply, then go down. So I'm going to shift to the right first. So I'm going to move right 1. So it'll be a graph right here. We're going to have a couple of extra graphs here as we figure out our information. Then I'm going to stretch. You're going to take care of your stretching and compressing. So I'm going to do my table here. It looks like we're at 0, 1, and 2 because we shifted right, because normally my parent guys would look like this, right? Whoop, that's a 0, 1. So we shifted right, so I added 1 to each of these. Boop, boop, boop. Okay, gonna stretch, so we're gonna multiply our y values by 2. So instead of being at 0, we would be at 1. We're actually gonna multiply that. So we're gonna go to 2. At 1, it was at 0, so that's gonna stay 0. And then at 2, we were at 1, so we're now gonna be at 2. I'm gonna stretch him then, do our new line right there. Right there. And now your third step, you're going to want to move up and down. So in this case, I'm going to move down 2. So technically what I'm going to do is take and subtract 2 from each of these y values if you want to think of it in the table form. So I'm going to go down 2 with my graph. 1, 2. This was a dot here, so 1, 2, and 1, 2. So my final graph, I'm going to delete all the other useless junk here. Is this graph right? Whoa! Is this graph right? Nope, that's... So the graph we're looking at is right here. That is this equation right here. That is the official answer. And that's the end of this video. We're going to go over a couple of examples more in class before we do our practice. But until then, see you later, Savers.